An insurance company knows that in the entire population of homeowners, the mean annual loss from a fire is $250, and the standard deviation of the loss is $300. The distribution of losses is strongly right skewed. Many policies have a $0 loss, but a few have large losses. Okay, so that explains the right skewness. If the company sells 10,000 policies, can it safely base its rates on the assumption that the average loss will be no greater than 275? Okay, so we're trying to figure out if their average losses will be, or what is the probability that the average losses will be bigger than 275, right? Okay, so we're going to let X be equal to individual loss from a fire, right? Okay, so we know on average, right, their losses are 250 and the standard deviation is 300. Okay, and we're trying to figure out the probability, what are the chances that the average of these losses will be bigger than 275, right? Okay, so let's go ahead and start our state. So state, okay, what is the probability that the average losses or average loss will be greater than $275. All right, so let's do our plan. Okay, so first off, we know that we are dealing with 10,000, and we know the distribution for individual loss from a fire is right skewed, right? But since we're dealing with our sample is so large, right, we can actually use the central limit theorem because this is definitely bigger than or equal to 30, right? So we can assume that the random variable for x bar, right, the random variable x bar has an approximate normal distribution, right? So we know that n is bigger than or equal to 30. So this implies by the central limit theorem that x bar is approximately normal. So let me put approximately, where the mean for x bar is the same as the mean for x, and the standard deviation is the standard deviation of x bar is the standard deviation of x over the square root of n, right? And this only happens when the 10% condition is met. Okay, so let's check this 10% condition. So 10% condition. So n is less than or equal to 1/10 of big N, where big N is all homeowners, right? Home, oh, I'm going to spell homeowners wrong. Homeowners, right? Of course, this is, so our N was 10,000, right? And of course, 10,000 is less than a tenth of all homeowners, right? Or another way to phrase this is 100,000. Let me fix this really quick. 100,000 is less than all homeowners, right? So that checks out. So let's go ahead and find our mean then. So this implies that x bar is approximately normal with mean equal to, so the mean of x was 250, right? Yeah, 250. And the standard deviation for x was 300 over that square root of 10,000. Oh, and then this is approximately equal to, or no, it's actually equal to 3, right? All right. So we have our distribution for x bar. We know that it's normal. So now we can do the do part. right? So do. You scoot down a little bit more. Oh, that was too much. Okay, so do. We want to find the probability that x bar is bigger than 275, right? Well, since we know that x bar is approximately normal, we can standardize it. So this is the probability that z is bigger than 275 minus 250 over 3. And then this is equal to the probability that z is bigger than 8.33. Rewrite this as probability, or I guess 1, right? 1 minus the probability that z is less than or equal to 8.33. But we can see, right? So our biggest value possible is this right here. Is this guy right here, 0.998, and that's for 3.49, right? So for 8 point whatever, that's even closer to 1, right? So it's practically 1. So this is practically equal to 1 minus 1, which is 0. So the probability that the average loss would be bigger than 275 is practically 0, right? So what can we conclude for this? Right? This means that it is very, very unlikely that the company would have an average loss more than $275. Oh, let me fix that. 275. So I need the money first. 275. Right? It would be basically 0.